This section is going to cover graphing trigonometric functions. And I know graphing's not everyone's favorite thing, but here's the cool thing. If you're coming out of our college algebra class, there was a lot of graphing in there. This is basically it for graphing in here is chapter 5, and it's 2 sections. So there is graphing and it's not easy, but it's short. So just spend a bunch of time learning these 2 sections, and then you'll be basically done with having to deal with graphs for the rest of the term. So bear with it, stick with it, and it'll be fine. So let's talk about graphing sine and cosine functions. Because the sine and cosine are functions, they have an input and an output. That means it should be possible to graph the functions on a rectangular coordinate system if the input and output can be identified. The inputs of the sine and cosine function represent an angle. So if we were looking at that, we'd have our angle, which would be called theta. Let's do a different color here that's going to show better. So our angle, which is theta, which means that we're taking the sine of theta. So our coordinate point is going to be the angle, and then the output when we put that angle into the sine function. So if you have your unit circle, which I have a small one right here, but I would pull out your big unit circle sheet, and we can use that to fill in these tables of values. So let's do some angles. So when our angle is 0, we're right here. Again, this sine is the y value, so the y value at the angle of 0 is 0, which gives us a coordinate point of 0, 0. When we're at the angle of pi over 6, the y value is 1/2. So that coordinate point is going to be pi over 6, 1/2. When we're at pi over 2, I'm just going to be, if you're wondering where these are coming from, I'm just kind of moving around and moving up so you guys get some special angles. So if we're at pi over 2, the y value is 1, so that's going to be pi over 2, comma 1. Let's do 5 pi over 6. Again, I'm just randomly picking them. There's no rhyme or reason. We'd have a y value of 1/2. So 5 pi over 6, 1/2. And then if we're at pi, the y value is 0. So that point would be pi 0. If we're at 7 pi over 6, the y value there is negative 1/2. So that's going to be 7 pi over 6, negative 1/2. If we're at 3 pi over 2, the y value is negative 1. So 3 pi over 2, negative 1. And then if we're at 11 pi over 6, we are at negative 1/2. So 11 pi over 6, negative 1/2 is our coordinate point. And then going back up to 2 pi, that's when we start repeating, because again, that sine function is periodic, so it starts repeating every 2 pi. So it's going to be 2 pi, 0. So what we can do is use these tables of values to actually graph the sine function in a coordinate plane. So remember here we've got our angle, and then you've got your y value, which again is the sine value at the sine function at that particular angle. So if I go to graph these points, I've got 0, 0, and then pi over 6, which pi over 6 is going to end up falling. So let's see, if I were to put this in terms of pi over 6, so pi over 2, to make it over 6, we multiply by 3 over 3. So this is the same thing as 3 pi over 6. So that must mean this is 1 pi over 6. Is about, so if I split this into 3s, so we've got, let's see, we would have 1 pi over 6 is about here, 2 pi over 6 is about here, and then we've got 3 pi over 6. So if I'm separating this out so that it's in groups of 3, this is pi, which is 6 pi over 6. So again, there's 3 between 3 pi over 6 and this pi over 6. Let's split this guy up. So this is going to be pi over 6, 2 pi over 6. And then we've got 3 pi over 6, so that would be 4 pi over 6, 5 pi over 6, and you don't have to label each one of these. And then here we'd have 7 pi over 6. There's the 3 pi over 2. So let's start graphing with what we know. So we've got the 0, 0, and then we have pi over 6, 1/2. So if this is 1, 1/2 is going to be halfway through. And then pi over 2, which is right here, 1. And then 5 pi over 6, 1/2. And then at pi, I'm at 0. So we've got that little part. And then at 7 pi over 6, I'm at negative 1/2, which is going to be about right there. 3 pi over 2, I'm at negative 1. And then we've got 11 pi over 6, so let's separate this guy out. So 11 pi over 6 is going to be the one that's right before 2 pi. So 11 pi over 6 is going to be negative 1/2 again. And then at 2 pi, I'm back up at 0. So the sine function looks like this. So that's the original sine graph. Now I'm going to show you some tricks with how to graph this. What I usually tell students, and actually, you know what, before I go into the tricks, we'll go into this. We'll get back to this in a minute. So graphing the sine and cosine functions. So when you're looking at these, when I go to graph these, we know that it's going to be a curve. So we've got our original point here, our end point is here, so it's 2 pi units before as it's periodic. And then we've got our maximum is halfway through. Halfway, I guess 1/4 of the way through. Halfway through you're back at the x-axis, and then halfway in between there you're down at negative 1. So we're going to define some of these words and how to understand parts of the sine function. So just like when you learn about parabolas and you learn about vertex and axis of symmetry, sine functions have these specific things as well. So what we call them is we've got, for the sine function, one of the special properties of it is called the midline. So what a midline is it's the horizontal line that's midway between the maximum and the minimum values. So you can see our maximum value is at 1, our minimum value is at negative 1. So halfway between that is going to be here at 0. So that midline is y equals 0. And then we have amplitude. So amplitude is the distance between the function's maximum and minimum values. Because the distance is always positive, the amplitude is always positive. So our amplitude here is going to be, so again, it's the distance. So to get from the midline to this maximum is 1 unit. Midline to the minimum is also, the distance is 1 unit. So we'd say that our amplitude is 1. So when I always tell students when you're graphing these types of functions is you've got your endpoint, your starting point, your endpoint, halfway in between you're at the midline, halfway in between those two you're at a max, halfway in between these guys you're at the min. All right, so now let's do the same thing for seeing what the cosine function looks like. So if I were to graph the cosine function, we've got at 0 you're at 1. I'm going to kind of stick with some easier points to get on here, but pi over 3, again, we already said this was going to be the same thing as, let's see, if I broke this up, this would be about right here. So we've got pi over 3, 1/2. And then we've got at pi over 2, I'm at 0. And then at pi, I'm at negative 1. 3 pi over 2, I'm at 0 again. And then at 2 pi, I'm at 1. So the cosine graph, oh my God, this is terrible. Let me redo this part. Clearly, I am terrible at drawing these lines. Okay, so the cosine function looks like this. I'm still really bad at graphing this. Okay, let's see what actually would look like pretty. So this is the pretty part of it, of how it should look. So if I'm looking at this, I can see that the midline of the cosine function, so again, that midline is halfway between your maximum and your minimum. So halfway between your max and min is that midline. So that midline is going to be y equals 0. And make sure when you're writing the midline, you're not just saying 0 because that doesn't make sense. A midline is an actual line, so you need to write it as the equation of a line. And then that amplitude, so the distance between the midline and the max is 1, the midline and the min is 1, so that amplitude is also 1.